Hey, hey. So, today we are going over the another large-scale model preview. Looking for my coffee. For Generative Pre-trained Transformer version 4, or also known as GPT-4. Tell me if you've heard of it. Let's just get right into it. So, I'm gonna watch this little this video with you of when GPT-4 launched. This was the developer live stream, I guess. So give this guy a little break. He's a little on the awkward side, but this is a little a YouTube shortcut of this.
A nice hand-drawn mock-up of a joke website. Definitely worthy of being put up on my refrigerator. So I'm just going to take out my phone, take a photo
of a drawing
of this
in a
mock-up.
book.
And here we go. And now we wait. And so we can actually take now this output. So literally we just said to output the HTML from that picture.
Based on the
and
sketch.
here we go. Actual working JavaScript, filled in the jokes. For comparison, this was the original
clicking. The JavaScript worked too.
Of our
That's
mockup.
the part that's messy.
So there you go.
And weird.
Going from
and
hand-drawn,
what's going
beautiful
on here?
art.
He just showed
if I
a
do say so
photo
myself,
of
to
a dumb
working
website idea to a robot, and then it wrote the code for it. Welcome to the modern turns of AI as of this year. So,
A nice
no,
hand-drawn.
come on. There we go. What the heck is this thing? What is this system? So, remember we're talking about computational models in this course, and the architecture that this particular large-scale system is based on is the transformer architecture. Yeah, it's called that because it transforms input text into output text. Transformer, right? It's arranged in a way there's a lot of stuff going on. I mean, it's a pretty generic name, but this is why it's landed on this name. It's an artificial intelligence modeling framework for building heavy-duty models, right? That's kind of the point. Typically used for natural language processing because they take an input of a sequence of tokens and then they output one token at a time, right? So, right. So it's normally natural language that you're using in this architecture, but it could technically work on any symbols, right? Language just happens to be a set of symbols that we're all very interested in. So it is a form of deep learning network. And remember, a lot of these terms will come up more as the course progresses, but it's a form of deep learning network. Lots of layers. Over here you see, again, you're not going to memorize this. This ain't important to your, this is not going to find purchase in your mind right now. But to illustrate, inputs come in, they go through many iterations of neural networks inside of the system, and they keep getting passed forward until eventually there is a classification at the end. Classification, well, again, we'll talk about that down the line, but that's the idea of I give you some kind of pattern, and you tell me, what is that? Using a symbol. If I show you a picture of a cat, and I say, what is that? And you say, that's a cat. That means you have successfully classified this complex image into one symbol, right? So the classification step in transformers, however large and however complicated they essentially are just, hey, what's the next token I should spit out? Tokens could be a word or a partial word or a letter, right? So the input text in these systems, it doesn't just take text and then have some big lookup table. It gets converted into these high dimensional vectors called embeddings. Embeddings are not quite symbols, right? They're a big wad of math is a good way to think of it. But the idea is that it tries to help you capture sort of the semantics of the words that are being input and not just the literal symbols, right? How that works, oh buddy, long, deep dive, not today. But essentially what it's doing is allowing us to run mathematical processes to ask things like, how related are two concepts? And rather than like, what are these words the same, right? So the networks are trained. This is the modeling part, right? Where we are modeling using lots of data and machine learning techniques, both supervised and unsupervised. So we'll get into a little bit about what those mean later, but the idea is lots of kinds of training are happening, and that's kind of the name of the game with these systems, with AI systems as they currently exist. It's about absorbing information from huge amounts of input data. It also, one notable thing that sounds very cognitive in nature, interesting, it has an attention mechanism so that the system can prioritize, how important are words connected to each other, like locally, not just, hey, you gave me a big bag of words, I'll do something with that. No, it preserves information about how relevant the words are to each other locally. It's able to focus attention in a way. Interesting. I'm actually going to pause for a second and edit this slide. You're going to see a magical, some colors pop into existence. Ta-da! Also, the background music jumped. Okay, just, I wanted to get that clear. So, right, this is the architecture, right? And these things can be very small. You can download the transformer architecture on your computer. These things aren't necessarily large. They can be, though, and that's where we get into the current era. So, as with other sort of large-scale models, let's talk about, okay, so if this is an architecture, what is the modeler doing? Like, if I go to make a language model, what am I doing in this system? So your goal with the architecture is you're trying to create a system capable of predicting, as with all models, right? But also, as we've discussed with computational modeling, generating natural language, right? So, and that natural language might be of a specific kind. Maybe you just want natural language of like, legal document reading, or you want natural language for how to navigate the DMV, or maybe you want natural language for try to simulate Reddit. What a nightmare that would be. But the idea being, if you build the model right, if you train it right, it's going to produce natural language in ways that closely resemble its training. Makes enough sense, I hope. So the transformer object, when you instantiate it, when you build it inside of a computer, it starts out fully constructed and all set up. You might be able to tweak some parameters of like, how many layers do you want? Don't worry too much about that. But it's essentially empty. It's just like a big lump of pseudo neurons that have they are connected to one another, but the values of those connections are all zero. No one node prefers another node in terms of activation. So you have a bunch of layers all set up, but they're kind of like null, right? So how do you get them full of something that's capable of producing useful output? This is where the modeler comes in, and we're going to provide it data and train it quite a bit. So their data preparation is one of the roles the modeler has. So selecting and pre-processing the training data so that it's like in a good form and ready to be fed into the transformer architecture. You do a lot of base training, is what I'm sort of loosely labeling this. It's lots of feeding your data set into the system. This is what's known as an unsupervised type of training. You're not saying there's a correct answer to a prediction. You're just saying, just read this and absorb the patterns. Because that one way of training a neural network, which we'll get into in the future, is read and absorb the pattern, wire together, adjust your weights based on inputs that are coming in. And you do this once, that doesn't sound like it does anything. You do it 100 trillion times or whatever, Now you're getting into a place where, oh, well, maybe some patterns will start to emerge in these connections. Again, how that works, we'll talk about it. It's called Hebbian learning. That's a preview. Fine tuning is the next step, which is you've gotten this sort of base coat in the model of like, okay, you have absorbed a bunch of the latent properties of language. Given one symbol, you know what other symbols are likely to come next, little classifier. Now I need you to fine tune towards things like being useful. Not just like recreating language at random, but recreating language towards a purpose. This is where we come into a supervised training, right? So you're saying, like answering questions, extracting information, analyzing sentiment, even the fact that they are now chatbots, that was a fine tuning. The ability for the system to like know that its goal should be to interact with another entity, and not just kind of like vomit out text that seems likely in the natural language world. So you have these two steps. You have the unsupervised step to sort of get like how does language work? How does whatever language this is being fed function? And then on top of that, goal-oriented fine-tuning to say, hey, there are right answers. I'm going to try and push you towards those in my model. So, and these training steps they're very automated. When I say modeler, in some of the other modeling stuff we've discussed, the modeler, writes the literal code of the system. But in this case, you're really just setting it and letting it run expensively for a while, right? A lot of computation involved. So the modeler is responsible for things like setting parameters in training processes, checking progress, all these kinds of things that they can tweak, but overall, you are letting it run through a lot of data that you have prepared for it, right? So at the end of this modeling process, you have a system that has captured the latent properties of language in the dataset and is geared towards some specific applied use case. Another quick pause, be right back. Okay, so, I'm not blurry, good. So, this is the idea. This is what the modeler is up to. GPT-4. Now, here we go. The current thing, right? The current, I've said this many times before, spaceship on the lawn. GPT-4 is the current state-of-the-art transformer model. You might see other discussions of that elsewhere, and there's other companies trying to keep up, but it's night and day. Some of them are getting okay, but GPT-4 is very powerful. And what does it consist of? How is it built? What is this model about? It's estimated to be about, because they won't share all their information, it's about 1.75 billion parameters. In AI world, parameters refers to the number of connections between nodes, and then like the relationship, positive or negative number that node will use to activate each other. We'll talk about all that later, but that's the idea. There's a lot of numbers involved in the system. So it's 10 times as large as GPT 3.5, which is the one you might know as base chat GPT, the free one. GPT-4 has been trained on billions of web pages, journal articles, forums, anything, not always with consent. OpenAI has a lot of explaining to do overall, but it's also built this tool. So, huge data set for its base training, right? It has base trained on, I just always refer to it as it ate the whole internet, right? Then it's been fine-tuned in a bunch of ways that allow it to achieve things that are kind of wild. Chatting is one of its fine-tuned focuses, again, because it needs to sort of like know the context of, I should be responding to this person as like a chat conversation, not completing sometimes the old ones, GPT-3, the base one, if you fed it a conversation like, this person says hello, it would just then like generate a whole conversation on its own, right? It didn't know that it was supposed to be like generating text towards like working with someone, right? So that's how the chatting fine tune has become so key to the way we interact with them. But tons of other fine tunes. Coding. Hey, become good at coding and don't just produce random things, produce things under certain constraints and certain values. Question answering, translation, summarization, sentiment analysis, content generation, creative writing, reading comprehension. Like, and that's just a few of them, right? So combining these two approaches, you get this was like incredible base coverage of both knowledge contained in and latent language properties of all the natural language in its data set. And it also has this highly flexible, adaptable skill set, right? So it's all those skills that it's been fine-tuned towards, applying knowledge and language capabilities. And remembering also, it's fine-tuned towards each of these, but these things also combine. Like chatting and asking it questions about code while it's translating between two different programming languages, it can do that. It combines these. It's not just, oh, well, turn on translation mode. Nah, it just has that skill. Whew. So, overall training costs are estimated by people who aren't OpenAI, because they are not sharing any of this. Estimated about $40 million, which, whew, you said I could make these at home. What are you talking about? That's the scale we're talking about here. They have increased the size and training data of this thing so damn much that it is now very expensive to train it. It is much less expensive to run, but this is why this is why they're not just like, oh yeah, here you go, everybody go do it yourself, because first of all, it might be dangerous to just let these things out. And also it's not as simple as, well, everyone knows how to do this now. You have to have resources as well. So this is the model. This is the model of the model du jour, the model of the year for sure. And I think it's useful to talk about like, why is everybody up in a tizzy about this thing? You know, well, so what? GPT exists and is a good model of language. Tell me something I don't know. I will. So, because of its intense training set and its size, that we haven't seen one of these at this size before. It boils down to, you can talk to it about basically anything, and it's got knowledge and language capabilities that it can apply in a wide variety of ways to help you out. This is why people are so scared about these things, like, oh my god, they can write my college essays. Oh, my five paragraph essay, the ultimate test of knowledge, is that it's really good at that stuff, right? It's very good at combining ideas and writing coherently and all these things. So, and to some finer points, right? You don't need to learn a technical language to use this system. They speak English. This is one of those points, those sticking points that people don't really pull together when we talk about like, hey, these things are going to be useful everywhere. You're right, because we've never had a system this technically capable and proficient that just speaks English. It just speaks your language, and other languages too. It's been trained primarily in English, but it's pretty damn good at translation too. To pull that around further, they pick up what you mean, right? It's not just like a set of commands that it has stored in some list. It gets you conceptually, thanks to those embeddings we talked about. The math, the abstract math of semantics of like the words you dump out into it, shove it, they focus it into the specific spaces of the language that it's consumed to give you the right kind of answers. So, yeah, they're good at picking out what you mean. The syntax of your language doesn't even really have to be coherent. You can say like, build computer, please, computer app, website. And it'll be like, hey, bud, sounds like you're trying to build a website. it gets what you mean, even if you spell things wrong and put words in the wrong order, because of this semantic space interaction, right? Reminder that things like Siri and Alexa, they speak exclusively in command barks, right? You say, Alexa, screen on, because you've had to learn the syntax that Alexa can accept. GPT gets what you mean. And again, I don't want to just sound like I'm a rah GPT is amazing, love OpenAI. No, it's just like first of its kind, and it is a new kind. So let's look at a video. Hope this starts the right spot. These are a little dry. It's from the intro live stream, same guy we saw before. I'm gonna put my headphones on so I can hear fella. This example is coding, debugging, and applying new information. We'll see. Let's go.
But next, I want to show you how to build with GPT-4, what it's like to create with it as a partner.
Notable, he's going to have, to give you a preview of where we're going with this, because it's a little bit of a long walk. He's going to have the system build a Discord chatbot using Python that calls GPT in Discord. It's very kind of meta, and not the company meta. We'll let him go.
And so the thing we're going to do is we're going to actually build a Discord bot. I'll build it live and show you the process, show you debugging, show you what the model can do, where its limitations are, and how to work with them in order to sort of achieve new heights. So the first thing I'll do is tell the model that this time it's supposed to be an AI programming assistant. Its job is to write things out in pseudocode first, and then actually write the code. And this approach is very helpful to let the model break down the problem into smaller pieces. And then that way, you're not kind of asking it to just come up with a super hard solution to a problem all in one go. It also makes it very interpretable because you can see exactly what the model was thinking, and you can even provide corrections if you'd like. So here is the prompt that we're going to ask it. This is the kind of thing that 3.5 would totally choke on if you've tried anything like it. But so we're going to ask for a Discord bot that uses the GPT-4 API to read images and text. Now, there's one problem here, which is this model's training cutoff is in 2021, which means it has not seen our new chat completions format. So I literally just went to the blog post from 2 weeks ago, copy-pasted from the blog post, including the response format. It has not seen the new image extension to that, and so I just kind of wrote that up in just very minimal detail about how to include images. And now the model can actually leverage that documentation that it did not have memorized, that it does not know.
Writing the actual code.
And in general, these models are very good at using information that it's been trained on in new ways and synthesizing new content.
So pausing that again, to clarify what's going on here, he's having it do a programming task. He's saying, hey, help me build this basic bot. The system has been trained on tons of information about like Discord APIs, so how to interact with the Discord chat tool, right? But he's also including new information just right there in the prompt about how to use the OpenAI API, so their API. So the bot is going to try to connect OpenAI's system to Discord's system. So you're writing the code in the middle to say, hey, go get a language guy over here and send it over to Discord. And he's including new information that the bot was not trained on to help it understand, oh, I should probably write it this way. Continuing this.
And you can see that right here, that it actually wrote an entirely new bot. Now, let's actually see if this bot is going to work in practice. So you should always look through the code to get a sense of what it does. Don't run untrusted code from humans or from AIs. And one thing to note is that the Discord API has changed a lot over time, and particularly that there's one feature that has changed a lot since this model was trained. Give it a try. In fact, yes, we are missing the intents keyword. This is something that came out in 2020. So the model does know it exists, but it doesn't know which version of the Discord API we're using.
So again, to help demystify some of the technical stuff going on here, this was certainly a developer's live stream. Discord, so the system knows a lot about how to write Discord API calls. It knows how to talk to Discord because it was trained on enough of that Discord, information. And by the way, it's incidental. Like, this thing ate everything it could find, everything OpenAI could find. They gave it to the system. Some of that was Discord documentation. Like, hey, how do you write bots for Discord? It just has all that enshrined in its language hypersphere, whatever you want to call it. But it doesn't know about this specific little update that happened to the way that Discord accepts information. It's like, oh, this thing blew up because of this error. So it got this error, continuing from there.
So are we out of luck? Well, not quite. We can just simply paste to the model exactly the error message. Not even going to say, hey, this is from running your code. Can you please fix it? We'll just let it run.
Says, sorry for the error.
And the model says, oh yeah, whoops, the intents argument. Here's the correct code.
Dear.
Now let's give this a try. Once again, kind of making sure that we understand what the code is doing. Now, a second issue that can come up is it doesn't know what environment I'm running in. And if you notice, it says, hey, here's this inscrutable error message.
Another error message.
If you've not used Jupyter Notebook.
So it writes code, and then it can read the error messages itself and debug them. You don't have to sit there and interpret the error message to help it understand what it should change. It just changes things based on the error message because that activates new, internal attention focus to say, oh, well, that makes sense. Here's a better version of the code.
Book a lot with async IO before. You probably have no idea what this means.
Yeah, no one knows.
But fortunately, once again, you can just sort of say to the model, hey, I'm using Jupyter.
You can get the error and give it
and would like to make this work. Can you fix it? And the specific problem is that there's already an event loop running, so you need to use this nest async IO library. You need to call nest async IO.apply. The model knows all of this, correctly instantiates all of these pieces into the bot. It even helpfully tells you, oh, you're running in Jupyter. Well, you can do this bang pip install in order to install the package if you don't already have it.
Yeah, it's always
that was very helpful.
Little clever things that I don't even.
Now we'll run, and it looks like something happened. So the first thing I'll do.
And so now
is
going to Discord and saying,
go over to our Discord.
Let's see if this works.
And I will paste in a screenshot of our Discord itself. So remember, GPT-4 is not just a language model. It's also a vision model. In fact, it can flexibly accept inputs.
So we don't need to get into all that. This is a truth, but it's also a little bit not germane. So I want to see this dang thing work. Did it work?
Code, and we can see that, yep, we in fact received the message, have formatted an appropriate request for our API. And now we wait, because one of the things we have to do is we have to make the system faster. That's one of the things that we're working on optimizing. Yeah. In the meanwhile, I
want a satisfying conclusion here.
Pretty good. Did not even describe it.
Okay, so this is GPT-4 accepting an image from the Discord bot that it just wrote, and then sending a message back. It did the processing. Yeah. So let's recap. This system is able to write code using additional documentation that you just hand it. If it screws something up, it can just read the errors itself and self-correct. And if there's something new that you need to add into the mix, you see an error that it maybe can't totally fix because maybe it wasn't trained up to the right time frame, you can give it more documentation. You can give it guidance. You can give it, you are interacting with it back and forth, and you just keep the wheel spinning. You just keep kind of pushing it towards like, hey, that's the direction we're trying to go. That balance is up to you. You can have it do most of the lifting on a thing and you just are guiding, but you can then decide to flexibly shift and be like, hey, okay, I'm going to take over. I'm going to edit some of the code. You send it code back and it says, oh, cool, I see what you changed. Let me add this, right? It's a collaborative effort. and good Lord, it's able to do a lot. We'll keep moving from here.
But next, I want to show you.
No. Okay. And to another part of this. This is arguably even more tedious, but it's pretty illustrative. So I'll just let him go.
So I have one last thing to show you. I've shown you reading existing content. I've shown you how to build with the system as a partner. The last thing I'm going to show is how to work with the system to accomplish a task that none of us like to do, but we all have to. So you may have guessed, the thing we're going to do is taxes. Now note that GPT is not a certified tax professional, nor am I, so you should always check with your tax advisor. But it can be helpful to understand some dense content, to just be able to empower yourself to be able to sort of solve problems and get a handle on what's happening when you could not otherwise. So once again, I'll do a system message. In this case, I'm going to tell it that it's tax GPT, which is not a specific thing that we've trained into this model. You can be very creative if you want with the system message to really get the model in the mood of what is your job, what are you supposed to do. So I pasted in
a bunch of tax code.
The tax code. This is about 16 pages worth of tax code.
Pages of tax code.
And there's this question about Alice and Bob. They got married at one point, right. And that here are their incomes, and they take a standard deduction. They file them jointly. So first question, what is their standard deduction for 2018?
You ask it to solve this.
So while the model is chugging.
Now, I want to point out, go back. Go back. Wait, did we rewind all the, oh my Lord. Why is it like this? I wanted to point out it has instructions here, right? So these system instructions are always available to the model. So its goal will be carefully read and apply the tax code, reasoning, give your calculations and your reasoning so everyone can verify them. So you're saying show your work and spell it all out in painstaking detail and don't skip any steps. As again, as any teacher would say to students, like, yeah, show your work. This is what's happening here.
So I pasted in is the basic standard deduction. Solve this problem by hand to show you what's involved.
Wait. Sorry. There we go.
So while the model is chugging, I'm going to solve this problem by hand to show you what's involved. So the standard deduction is the basic standard deduction plus the additional. The basic one is 200% for joint return of subparagraph C, which is here. Okay, so additional doesn't apply. The limitation doesn't apply. Okay, none of these apply. Oh, wait, special rules for taxable year 2018, which is the one we care about, through 2025, you have to substitute 12,000 for 3,000. So 200% of 12,000, 24,000 is the final answer.
Taxes are not exciting, but
if you notice, the model got to the same conclusion, and you can actually read through its explanation.
Its reasoning.
And to tell you the truth, the first time I tried to approach this problem myself, I could not figure it out. I spent half an hour reading through the tax code, trying to figure out this like back reference and why there's subparagraph, like just what's even going on. It was only by asking the model to spell out its reasoning, and then I followed along, that I was like, oh, I get it now. I understand how this works. And so that, I think, is where the power of this system lies. It's not perfect, but neither are you. And together, it's this amplifying tool that lets you just reach new heights.
So
and you can go.
We'll pause there and move on. Little bit of like marketing spin there, but it's right. I mean, it's not perfect, but no one is. So like no one who produces language is ever perfect. So this thing is demonstrating a capability of spelling out how it does things and educating you, right? Educates you right back. It can be a tax tutor, because while it could get things wrong, and it can get things wrong, no illusions about that. What's called hallucinations. It can confidently, accidentally start on a track where it gets very wrong. We'll talk about all that down the line. But the core idea here being that, like, take this complex process, have it work through it in a way that you expect it to be able to handle it, and you can check if it's correct at each step. And if it is, and you didn't know those steps before, now you're learning. You're picking up the chain of reasoning you require to do this task that you may not have been good at before. It's all for a single call, and it takes like 12 seconds to generate. So, okay. those are some examples. I can remove this. Blah. Big foamy headphones. So those are some examples of, the developers themselves showing you some fairly dry, but I hope interesting examples of how these things are used. They also have, as we showed, in one of those videos and in the early video of like, hey, take a picture of a website and make it for me. It also has vision now. And as of writing this, October 2023, this feature finally dropped. Like not, I don't think everybody has it. It's one of those slow rollout things, but it's available now. I've used it. So the system can take photos along with language in its input. And that photo ends up processed in a variety of ways. We don't know what all they are because OpenAI is not especially open. But what it results in is this wildly deep, flexible, comprehensive interaction between the language model of GPT-4 and the image analysis system that's attached to it. Early on, when they were first launching this, they talked about the company Be My Eyes is actually where this comes from. It's responsible for the image processing, because the goal of Be My Eyes is to be a scene parsing image to language tool to help aid visually impaired folks, right? And not just like super raw, like, oh, I'm describing every detailed pixel, but sort of giving a human natural language description of the scene, whatever's happening. Let's walk through my example that I experienced. So, at this point, you're familiar with this mug. It's a little dingy, a little old. It's a long-running mug of mine from my home of Michigan, my origination point of Michigan. I started in with, hey, what's this? Now, okay, pausing here. You'll see that GPT is using a lot of it's like not using capitalization, and it's using this sort of informal form. This is a personality I've crafted for it just for fun, and also some curiosity about how that changes the behavior of the model. But it's kind of like big millennial energy type vibe. So get over now. Like, oh my god, it speaks like it's talking like a text boy, and yeah, it is. But continue focusing on the content as well. So that's a dope mug of Michigan design on it. It's got the vintage Water Wonderland. Even points out Mackinac Bridge and Lansing, which are key pieces of Michigan lore, and really Lansing's the capital, and Mackinac Bridge is one of the biggest landmarks between the lower and upper peninsula there, right? So it's just like, hey, cool, nice thing you have there. I start interrogating. What do you think it's made of? Based on the pic, probably ceramic. Pretty common for mugs. There's a glaze on the outside that it can see. It notices the glaze. It's got that smooth, shiny finish. Yeah. Shit's artsy, man. I had to tell it explicitly, you're allowed to swear for emphasis. Just don't be mean. Just like me. What color is it? It's kind of off-white or beige, brownish. Inside looks darker, maybe black or deep brown. What would happen if I turned it upside down? Well, if there's anything in it, you're about to make a mess, my dude. But if it's empty, then it's just going to sit there. But any leftover liquid drops, be careful of those. I'll tell you, I'll spoil it. There were leftover liquid drops. It was right about that. How tall do you think it is? Tricky to say, maybe 4 or 5 inches tall. Just a guesstimate. Better whip out a ruler if you want to get precise, okay? What do you think it weighs? If it's empty, a lot of mugs like this would be 10 to 16 ounces, but it's pretty thick, so probably on the upper end of that range. Hard to know. Again, it sort of understands its own limitations in some ways here. When do you think this was made? Are they still sold like this? Water Wonderland slogan, probably retro, maybe in the 1960s or 70s. Michigan used Water Wonderland as a license plate slogan in the 50s and 60s, so that could be a clue. Okay. As for whether they're still sold like this, hard to say. You probably find it on Etsy or eBay or things like it, so try there. Might be a bit rare these days. Okay, my vintage mug. And then finally, I asked it, tell me what is the most subtle detail from this image that someone might overlook. Right now we're getting into the insights, the deeper comprehension. And it's saying, okay, diving into the details, you might overlook the texture, slight imperfections on the mug's surface. It can see the imperfections. It's not completely smooth. There's little bumps and irregularities. There are. These details hint that it might be handcrafted. It is. And another subtle hint, faded nature of the design. So it's been loved and used quite a bit. So let's recap. What has it said? It's a mug. It identifies it as a mug. Just from a single image. It's identified it's a mug. It recognized all the text and the fact that there was a slogan there, a relevant slogan. It knows that it's glazed ceramic in material. The color, it says, is beige or off-white, maybe black or deep brown with the colors. Action, it will spill if it's not empty. Beware trickles. Height is 4 to 5 inches. Weight is 10 to 16 ounces. History is probably 60s or 70s. You might find it on eBay. Nuances, small imperfections imply it's handmade. And the faded look implies it's used and well-loved. There's no outside information. This version of the GPT interaction is just the language model as it is, with no, like, it can't, like, search Google or anything. It's just the language model as it's been trained, the pre-trained version, and this photo, and then me interacting with it, with the language. And it can't search with images right now. And it's a single photo and a conversation with the model in its default state. I didn't even really give it guidance. I just kept probing it with new questions. Well, let's see how it did. Oh, I left a little square up there. Well, you'll see what's in there later. Mug. The actual mug. It is a mug. It is the Mackinac and design and slogan. The Mackinac text and the slogan. It is glazed ceramic. It is beige and dark brown. I did actually spill trickles when I tipped it over. It's exactly 5 inches tall. It weighs 760 grams, so 1 pound 10 ounces. It's about a pound heavier than the robot thought. Shame on it, right? The only result that I could find when trying to figure out the history was eBay, and it is in fact from the 70s. We'll see a picture in a sec. And it does have incredibly small glaze imperfections that do in fact imply it's handmade. And it is the Mackinac historical attraction in Michigan. And it is in fact faded and well loved. It was my dad's. So this is the eBay listing for this same kind of mug. They don't say like when it was made or anything, but it is like a souvenir Mackinac Bridge souvenir mug, vintage. And I know Mackinac Island is the place where these things are made, just because of, Michigan history. They're very like, we do things like churn our own butter and we build things and we kiln things. It is handmade, guaranteed. Another version, a similar one of a different kind. Oh, geez, my little pink highlight screwed up. It is from the 70s. So this is the same style as the other from the 70s. And the imperfections are present. The dents and the dimples that it could tell. Or it inferred some of that from the language of the conversation we had. But either way, it's doing a lot of work. So, let's check our score sheet. The assessments, again, that GPT made about this mug. It is a mug. It got all the text and it recognized the slogan. It is glazed ceramic. It is beige and deep brown, I'll give it credit for. I put these in a like different color because it's sort of like it covered its bases a little, just to be slightly conservative there. Action, it will spill if it's not empty, and it was right, the trickles do come out. It was exactly 5 inches, so it guessed 4 to 5. It was off by a lot on the weight, but I mean, hey, it's a tricky mug to assess. And history 60s or 70s. It suggested I could find it on eBay. It was correct. And then it has these small, slight imperfections implying that it's handmade. It is, in fact, handmade. It does have those imperfections, and it looks well loved. It was my dad's. So, from a single photograph, without searching the internet, I didn't even really help. I just probed it, and it was able to extract all of this, combine it with its like huge information stores, and make all these really good either direct assessments of the image itself or assessments of the image combined with its knowledge base. Knowledge base being itself, right? The weights of the connections of the model. Just trained right in. What is going on? What the absolute hell is the title of this slide. And look, here's where it's just kind of like you take a step back and you consider, dang, I just talked to a robot about a single photo of a mug I inherited from my father for nearly an hour. It might have been like half an hour, but it knew more about it than I did just by glancing at it. A single photo. It didn't Google anything. It didn't have the capacity to externally find other information especially not that quickly, right? That's the thing about these things, is they produce information fairly fast from their trained weights. So it combined features available in the image with its vast stores of knowledge to give this shockingly accurate answers to all the questions I could think to throw at it. And this is just like the kind of the dumbest use case. Like, take a picture of a thing and just like ask it questions about it. Cool. There's other routes. And so to highlight what this interaction demonstrated from my perspective, it demonstrated a lot of visual capabilities. So reading capabilities, it could actually see the text as text. It's not always great at that. I've tested a lot of other ways with this. It can really mess up the text sometimes. It has nuanced color vision. It can detect texture and material. It can make size estimates, weight estimates, although the weight was a little off this time. We'll give that credit. And as far as like insights and reasoning go, it understood naive physics. It knows what would happen if you flip this thing over, and even the edge case of if it's not quite empty all the way. It has the historical knowledge that it has of the system implied the age and where to find it. It guessed the age of when this thing was made. And as far as the subtle defects implied that it was handmade. The fadedness implied that it was well loved. These are things that it was right about based on its sort of, I'm not going to call it guessing, but based on its sort of not fully informed take. It was quite informed ultimately. So, this brings us to sort of a question. This is a course about modeling human cognitive processes. Why are we talking about this crazy AI robot? Dang it. So there's like using a language model as a model of cognition? This is where it's getting kind of weird. We're in a sort of a new phase. There's a transitional period occurring under our feet. So by design, this AI system, no, there's no human-based constraints or predictions about like, this is the way that human cognition functions, right? We're trying to model just kind of like the output of language. No constraints, as big as you want, as much training as you need. I'm not going to make you do it like a human. I'm just going to make you do it, right? That's the kind of the conceit of this kind of AI modeling. But in effect, well, it's not totally clear. Not necessarily is this anything like human cognition, but that's up in the air as far as like what we're seeing it develop, right? Because GPT-4, it's not at all an explicit model of human cognition, neurology, anything like that, but it has been trained on the outputs of those systems, right? The outputs of humans typing things, the big old block of human-produced language spanning the entire internet. And it does have, at minimum, some similarity to human informational systems because it has a node-based network similar to our neurons that is its informational structure. So combining those two, like it's not identical to the actual neural networks in humans, but it does have some of those shapes. It's nodes connecting to each other and being able to produce these really complex patterns out the other side. So the question they're poking at is, if we're training it to produce the same outputs as such a cognitive human person system, just by having, in mass, right? And it shares some structure a little bit, then the question is, what has it absorbed from us, from the language? Are there human cognitive structures that it has reinvented in its machinery? Crap. So it's quite possible we've accidentally, as a technological culture, have accidentally kind of backed into modeling human cognitive properties just by having this robot eat the whole internet. So this, take this with a grain of salt, but this is kind of the dawn of a new field in AI, a new field of like AI psychology, which is applying psychological experimental techniques to say like, hey, AI is a big black box that we're not quite sure how it works, but it does complex things, just like people do. I'm not saying it does them the same way people does. Well, I am saying it is an interesting, complex system that we don't fully understand from the outside, right? So this new era of trying to figure out how these systems work and what they're actually doing internally with external methods, just like psychology did. So, quick aside on emergent behaviors before we take off. Maybe not quick, but important aside. So, emergent behaviors. It comes up all the time, but it's very closely tied to the concepts of like complex systems, right? Complex systems that you can't necessarily model in a closed form way. You have to model them behaviorally. So when you gather together large numbers of small components that operate on simple rules, right? Those components, say maybe being a neuron, it has relatively simple rules about how it's supposed to do things, but they're massively interconnected. You start to see behaviors that aren't explicitly defined anywhere, right? They emerge from the interactions of the system's parts. So think of flocks of birds, how they move through the sky together. No one designs how that bird flock flies, but they do all have rules. Each individual bird has rules that say like, here's about how far away I should be. Why is a V the right way? It has to do with the properties of airflow and all those kinds of things, but the pattern comes out because the birds themselves are following simple rules. Schools of fish, corporate entities, like let's jump up the scale. These systems don't behave, they're not people, despite what the Supreme Court has once said. They're not a person. They're a higher order entity that has strange behaviors that individual people might not agree with, right? Even if all those people in the company all behave that way. Bundles of neurons, right? So one neuron does a thing, but a big old bundle of neurons does a bunch of other things, a bunch of new things. Things like being able to compute calculus equations, right? Sociopolitical movements, like another very large-scale complex thing that might have simple units. Weather patterns, right? Like a water droplet, not too hard to describe how that thing moves through the air, but huge systems of interacting, fronts. Ooh, buddy, that's harder to do. So because these complex emergent behaviors aren't defined, right? They emerge from the interaction. Our only choice is to model them in this computational way. This like behavioral, one step at a time, model all the parts, because we don't know the process that we're modeling. This is, to pull this idea back into the AI context, the emergent behaviors are the complex tasks that the AI model can perform, which weren't explicitly programmed, right? I sat down with this model and I interviewed it about a mug. No one gave it specific data on that mug. It pulled together data from all kinds of sources that it had consumed, and it was able to have a conversation with me about it, right? Not explicitly programmed, and they emerged from how the model's informational system was set up by the data that it trained on. So this emergence really starts to happen when you scale up, right? This is why the jump between 3.5 at 1/10 the size to GPT-4 at 10 times that size was huge. It's like a night and day change, because these properties these complex capabilities of reasoning and things like this have only emerged because the size was big enough, unlike the former models, right? And I say size and also the amount of training data, because you could train a gigantic thing and say like, oh, here's one paragraph. Like, it wouldn't be very good. So it has to have a lot of size and a lot of bandwidth and a lot of data, right? So a takeaway to this discussion that I want you to internalize is, even the developers of complex AI systems don't know what capabilities will emerge until they actually try it. These are not capabilities that were explicitly programmed in by some divine hand. They are abilities that come from guiding the complex interaction of training towards some goals that we hope it can do, and then seeing, holy crap, it's got theory of mind now, and it developed tool use, which is this evolutionary skill that most animals still can't do. It's like us, monkeys, crows, and dolphins, or something, maybe elephants. It just evolved tool use. GPT 3.5 couldn't do tools. Maybe now it's been trained towards that a little bit, but GPT-4 had tool use out of the box. Yes, that's a little disconcerting. And also wildly fascinating. My personal side of this is that I've got a PhD in cognitive science. I am well tuned to the expectations of AI capabilities and emergence and stuff. I genuinely didn't think we would see this in our lifetime. I genuinely did not. I was going to die way before AI started taking off, but here we are, right? So the spaceship has, this is the way I keep phrasing this, the spaceship has landed on the front lawn. So we got to get to work understanding it. That's our job. I'm here to help me illustrate the spaceship on the front lawn. Midjourney helped me out. A spaceship landed on the front lawn, ominous. View from inside of house out window. Vaporwave, dark, stylized. Y'all should mess with these things too. I know there's a lot of ethical concerns, and they're all valid, but dang, what a weird world we're in. So, I do have a tip. I don't have a textbook for this course, and I'm not going to require any of this. Because this course is going to have some GPT-4 interaction just like baked into it, sponsored by me, right? You can look forward to that. But I do have a personal recommendation. Scrape together $20 and pay for 1 month of GPT Plus, and just start using it, right? Try conversing with it towards brainstorming or completing some task, or especially programming it. It's great at, and like make it a back and forth. Remember, don't just like have it, oh, do my homework, please. Because it's this tool that is simultaneously, and I want you to kind of like wrap your head around this. It's an infinitely patient tutor. You can ask it as many questions as you want. It will never get tired of answering them. It's a motivated collaborator. It really is attempting to help you solve whatever problem you're working on. It's an extremely informed domain expert. It's not perfect, of course. It will make things up sometimes, so make sure you're bringing your own brain to the table and can check its work as well. But it also takes feedback extremely well. If you say, oh, I didn't like any of that, it'll be like, oh, well then what are you looking for? It doesn't care. It's not upset that you didn't like its output. It's just, again, it's a super motivated collaborator. So that's the pitch for why this thing is a useful tool. And again, it's cheaper than a textbook that you'll barely ever read, right? So, but here's why I'm suggesting this from the standpoint of the curious mind, right? I'm not assigning this to you. I'm suggesting you should get into it, because as the main refrain of this course goes, you're not going to understand this complex emergent behavior of like a successful interaction with the chat system as like GPT as an assistant by trying to just like sum it up at a glance and say, I get it. You're not going to. You can't. I'll show you some things along the way for sure to help illustrate this, but you got to go step by step through the behavior. You got to see how you're able to steer this thing through a complex task space just by talking to it with regular words. It's something if you haven't done it yet, you've never done it before. I know that's a tautology, but like, it's not the same as what you think. If you haven't used it yet, give it a shot. Because remember, you have to iterate with it. You can't just mindlessly ask it to do your homework. That's the way that everyone talks about these tools being used right now. Oh, they're just gonna make it do an essay for them, and then they're gonna get away with cheating themselves out of education. Don't be that guy, because that's not how this works. That's not really the use case. The use case is you bring your skills, and you have the most capable tool in your sidecar, and you're combining. You are doing things with the system, not asking the system to divine it for you from the ether. So, just a tip. I suggest this. Get into it. You know, $20 ain't nothing. It's still $20 is $20, but it's worth a shot. It's worth dumping some into it. Also, I know I sound like a shill. I'm like, oh, go spend money at this corporate, but I mean, this is the only way to get consistent access right now. So, give it a shot. Okay, if you don't, remember, I provide the basis within the course for how we're going to use it. So, key takeaways. We're going to come back to transformers and GPT later in the course once we've discussed more of the constituent parts. You know, I mentioned like, oh, Hebbian learning and nodes in a neural network, right? Like, we haven't talked about any of that stuff yet. So, that's where we're heading. We will stop by all of these explanatory pieces on the way, and then we'll come back and talk about these things later. So, for now, the key takeaways to have in mind are its transformer architecture is one of many shapes that AI has taken in the past, this neural network shaped AIs, and it's primarily focused on language and symbol sequences. But scale is everything in these systems. You know, you may be able to download the same transformer shape as GPT-4, but you don't have, you know, your computer would probably take 795 years, not joking, literal like processing time for one computer to train GPT-4 the way it is, right? So scale is huge, and GPT-4 represents the current state of the art because they threw tons of resources into it. So they scaled up the size and the training data to create this most competent AI model anyone's ever seen. And, you know, not just in terms of modeling language, but in terms of producing behavior and successfully engaging in and completing tasks. Its capabilities are genuinely freaky. They emerged by accident, and this is just the beginning. So, yeah, okay. We've run over an hour. That's it for now. Give it a look, or at least start like consuming content based on it. Maybe I'll include some YouTube channels to keep abreast of this stuff. But yeah, we're in a weird era, guys. It's getting crazy. Take care. Talk to you soon.